All right. So now that we're familiar with the performance-based design process and the ideas behind it, let's take a step further and look at the references, standards, and guidelines that are available for us to use. Now, here's something important. Performance-based design is still a relatively new topic. In many countries, the local building codes haven't yet fully developed dedicated provisions for it. Most of them just give short, brief mentions of the approach. So, in practice, we often have to refer to well-established international standards, especially from countries that are ahead in this field. And of course, over time, local codes will catch up. In this course, we're going to focus mainly on two major standards, one from the United States and one from Europe. And we'll go into both of them in detail, following the performance-based design process according to these codes. Now, let's go through a quick overview of the key documents out there. In the United States, we have ASCE 41. This standard is primarily aimed at the evaluation and retrofit of existing buildings, but the process it outlines can also be used for modeling new structures. The most widely used version is the 2017 edition, and there's also a new 2023 edition that was released recently. The latest version goes into much more detail on nonlinear modeling, especially for both steel and reinforced concrete structures. And it's actually split into two volumes, AISC 342 for steel and ACI 369 for concrete. It's worth noting that the older version included everything, evaluation, analysis, and nonlinear modeling, all in one document. But in the new edition, the nonlinear modeling part has been separated into its own volumes. Over in Europe, we have Eurocode 8, which was first published in 2004. It gives a brief mention of performance-based design and pushover analysis. There's also a new draft version from 2023 that's currently available. Another important reference is FIP Bulletin Number 24, published in 2003, which focuses heavily on the evaluation and retrofit of reinforced concrete structures. There hasn't been a newer edition of that one yet. From Turkey, we have the TBI 2018 code, which is also a strong reference, and it includes provisions for nonlinear modeling and pushover analysis. Now, most of the documents I've just mentioned focus more on evaluation and retrofit of existing structures, but their nonlinear modeling procedures are still highly relevant, especially the ASCE 41 2017 and 2023 editions, which are really the main international references for nonlinear modeling. There are also guidelines that specifically address performance-based design for tall buildings. In fact, we have several volumes, 3 American documents and 1 European one, that cover the approach to design, and also give some brief notes on nonlinear modeling for these systems. These include the TBI Guidelines 2017, Latest DC 2023, the CTBUH Guidelines 2019, and FIB Bulletin 73 2014. Now, besides the codes and standards we've just talked about, there are also a lot of guidelines out there that can help us with the process of nonlinear modeling. Because here's the thing, if our modeling isn't realistic, we simply can't rely on those models for performance-based design. The core of performance-based design is nonlinear modeling, and this is a topic that's full of details. It really needs to be covered thoroughly and in depth. Among the many resources available, we have 4 NIST documents. NIST 46 version 1 to version 3, and NIST 45. These were published in 2017, and they're high-quality references for both steel and concrete systems. They provide excellent detailed rules for modeling and acceptance criteria for structural components, really comprehensive information. We also have Powell's 2010 book, FEMA 2091 for modeling soil structure interaction, NIST 917 2015 for selecting and scaling earthquake records, and ATC 72, which is essentially the older generation of the NIST 46 and 45 documents published in 2010, also covering nonlinear modeling for different systems. Then there's FEMA P2006, which gives examples of how to apply the ASCE 41 approach for evaluating and retrofitting existing structures. And finally, as we mentioned earlier, the two volumes AISC 342 and ACI 369 focus on nonlinear modeling for steel and concrete systems, and form the Nonlinear Modeling Core of ASCE 41 2023. Now, in this course, we're going to show you how to do nonlinear modeling, how to model and implement it in software, based on the latest editions of the codes and guidelines currently available. We also have plans to release a dedicated course just on nonlinear modeling, covering different structural systems in detail. So stay tuned for that as well. And finally, thank you for following along with us so far. We really appreciate you being here. Make sure to continue the next sessions with energy and motivation, and we truly hope this course has been useful for you up to this point. We wish every single one of you success, and we hope you all become professional engineers in the very near future. All right then, see you in the next session. Bye for now.